To solve simultaneous equations involving one linear equation and one quadratic equation, you need to use a substitution method from the linear equation into the quadratic equation. 2x plus y equals 1 is the first equation. X squared plus y squared equals 1 is the second equation. First, rearrange equation 1 to get y equals 1 minus 2x. Then, substitute this into the second equation in place of y. So, it's x squared plus y squared equals 1. Substituting 1 minus 2x instead of y gives us x squared plus 1 minus 2x squared equals 1. So, x squared plus 1 minus 2x times 1 minus 2x equals 1. Expand the brackets and simplify. Then, x squared plus 1 minus 2x plus 4x squared equals 1. Collect the like terms. So, 5x squared minus 4x plus 1 equals 1. 5x squared minus 4x equals 0. Solve for x using factorizing. So, x times 5x minus 4 equals 0. X equals 0 or x equals 4 over 5. Now, find the corresponding y values by substituting the x values into the first equation. So, for x equals 0, y equals 1 minus 2 times 0, y equals 1. And for x equals 4 over 5, y equals 1 minus 2 times 4 over 5 equals 1 minus 8 over 5 equals minus 3 over 5. The solutions are x equals 0, y equals 1 and x equals 4 over 5, y equals minus 3 over 5. As you can see here, there are two solution pairs for x and y. Simultaneous equations with one linear and one quadratic equation can have up to two pairs of solutions. Remember to make sure the solutions are paired correctly. X minus y equals 6 is the first equation. Xy equals 4 is the second equation. Rearrange the first equation to get x equals 6 plus y. Substitute 6 plus y into the second equation in place of x. So, xy equals 4. Y times 6 plus y equals 4. 6y plus y squared equals 4. Y squared plus 6y minus 4 equals 0. You cannot factorize this. So, here complete the square for y squared plus 6y. So, completing the square for y squared plus 6y gives us y plus 3 squared minus 9 minus 4 equals 0. Y plus 3 squared minus 13 equals 0. Y plus 3 squared equals 13. Taking the square root from both sides gives us y plus 3 equals plus or minus the square root of 13. So, y equals minus 3 plus or minus the square root of 13. Now, you can find the corresponding x values by substituting the y values into the first equation. So, for y equals minus 3 plus the square root of 13, x equals 6 minus 3 plus the square root of 13, x equals 3 plus the square root of 13. And for y equals minus 3 minus the square root of 13, x equals 6 minus 3 minus the square root of 13, x equals 3 minus the square root of 13. The solutions are x equals 3 plus the square root of 13, y equals minus 3 plus the square root of 13, or x equals 3 minus the square root of 13, y equals minus 3 minus the square root of 13. 3a plus b equals 8 is the first equation. 3a squared plus b squared equals 28 is the second equation. Rearrange the first equation. So, 3a plus b equals 8, b equals 8 minus 3a. Substitute b equals 8 minus 3a into the second equation. 3a squared plus b squared equals 28. So, 3a squared plus b squared equals 28. 3a squared plus 8 minus 3a squared equals 28. Expanding the brackets gives us 3a squared plus 64 minus 24a plus 9a squared equals 28. 12a squared minus 48a plus 36 equals 0. Now factorize. So, 12a minus 36 times a minus 1 equals 0. So, a equals 1 or a equals 3. Use the first equation to find the b values. So, for a equals 1, b equals 8 minus 3a equals 8 minus 3 times 1 equals 5. And for a equals 3, b equals 8 minus 3 times 3 equals 8 minus 9 equals minus 1. The solutions are a equals 1, b equals 5 or a equals 3, b equals minus 1.